All right. Welcome, everyone. Are we properly caffeinated? It's OK, I see some cups. OK, because it's getting pretty late in the day. So although I have a very cheerful and uplifting title, I must warn you that it's going to be ugly. And we're going to spend almost an hour talking today about something relatively new in C++, and that is string views. My name is Victor Ciura, and I've been programming C++ for over 15 years now. I've been working on a product called Advanced Installer for 13 years. And lately, I've been involved with an open source project that we started with some of my colleagues, Clang Power Tools. You can reach out to me on Twitter, and you can figure out my email address if that's needed. First of all, this is part 1 of N of this talk. I plan to study this a bit more, and already I received plenty of feedback on my ideas, and people are really interested in this topic. And depending on how well it goes, this might be one of N, or N might be just one. So why string view? Why are we talking about string view? Why are we talking about strings? Have you really exhausted all the cool C++ template tricks? That seems kind of boring, talking about strings. Well, wouldn't it be nice if we had a standard string type that we can use all over our systems? Well, we do. Standard string. It's right there in the standard. Name is obvious. But wouldn't it be nice if we could use this standard string throughout our project and our applications? Well, unless we're writing just services or console applications, it's kind of difficult, because at some point we do need to interact with GUI frameworks or operating system APIs, and that's when things start to become complicated, when we do need to interact with some other form of string type. Be it we're talking about C family of APIs from the operating systems, or some more or less modern GUI framework with its own string type. So depending on your situation, you might be facing using ATL CString or MFC CString, or the modern Windows platform string from WinRT, or QString, Foley FB string, whatever, depending on your project. By the way, WTF string is just from WebKit. I'm not being nasty here. So depending on your string type, there are various considerations that each project or each foundational library has had to think about over the years. Things like, does it support small string optimization? Nowadays, most string classes support small string optimization. Does it implement something like copy on write? For example, the standard string is no longer allowed to do this kind of optimization. But many of the platform strings and framework strings do implement something like copy on write. For example, ATLs or MFC's CString. Is it thread safe? Can I customize the char traits? Can I customize it with a custom allocator? Does it play well with string literals? Or can I use it in const expert context? Does it support encodings or locales? Does it have full support for Unicode? Well, many other such questions come up. But we're not going to focus on any of those today. Well, C++ superstring to the rescue. No, seriously. There's a project on GitHub that's called superstring, and apparently it's very efficient in some situations. It actually uses some kind of rope structure inside. you should check it out. But on a more serious note, so you end up with, let's call it XString, which is your platform or your framework string. And you have standard string, the one that you use in your models and in your business logic. And you have to interact somehow with those. And you can use the common denominator. They can all decay to some kind of pointer to a char. And you end up using some glue code. You say, OK, I'm going to use the standard string in my serious business logic code. And I try to maximize the usage of standard string. And when I have to interact with some framework or the operating system, I use that proprietary string type. And of course, some unnecessary copies are needed in order to transport data between those two types and adapt them. But we call that glue code anyway. Doesn't matter. It's not going to be pretty, but it's small. But what happens if, over time, you start building up a collection? As your project goes, you start building up a collection of utilities and algorithms based on strings, various manipulation methods that you might need. And that collection grows over time. What do you do? Do you constrain yourself to just using those algorithmic goodies to standard string? What if I want some string helper or string algorithm that I've developed, and I want to use it for some UI strings? For example, using MFC CString or platform string. So do we duplicate that code? Do we implement the algorithm using a const char star and lose the type safety and the nice goodies that come with a typed string type, string class? Well, some people think that string view is the solution. String view, for those of you who haven't seen it before, is a new type in C++ 17. What we have to figure out is, string view is the answer to all our problems? And we'll try to figure this out together in the next minutes or so. But first, on a more serious note, how many of you are still stuck on some old compiler? OK, a few hands. How about C++ 11? OK. 14? A little better? No? I'm losing hands here. 17? Oh, good. Good. So just in case C++ 17 is off limits, there are alternatives. Like Andreas talked earlier about AppSale. You have AppSale string view, string piece. This is an older one from Google. String ref from LLVM. Boost string ref, or Foley range. I do have to give a special shout out to AppSale. How many of you have heard of AppSale from Google? OK, good. So AppSale string view has pretty good documentation on it. I've put a link there for reference. It explains the rationale in its existence, gives good example, and some of the gotchas. Some of them I'll cover in this talk as well. And AppSale itself, for those of us who haven't heard about it, it's an open source collection of C++ library code that it's designed to augment the standard library, not to replace it. And it basically adds new utilities that are usually in modern C++, like C++ 17 or coming in C++ 20. And they add it as being backwards compatible with older compiler toolchains. So it's like a transition clutch, so to speak. And you have very useful stuff in there. Do you remember Herb Sutter's Guru of the Week series? The older of you probably still remember that. I used to read those. Well, they do something similar with AppSale tips. I highly recommend that you read through those and subscribe to any new stuff that comes in. They're very useful. And here's the link, appsale.o/tips. Lots of interesting stuff, some of them complementing the core C++ guidelines, some new stuff in there that you won't find in the CPP core guidelines. Very useful stuff. And I like the format as well. Lots of examples and short rationales. And wouldn't you know, the very first tip is about string views. So definitely check that out. But let's get into the meat of the problem. Let's meet C++17 string view. This is roughly the overview definition of it on cppreference.com. It is meant to be a class template that describes an object which can refer to a constant, continuous sequence of char-like objects, the keyword being constant here. And conceptually, a typical implementation is a pointer to a constant char and a size. So very simple. What could go wrong with that? It has almost the same interface as standard string, except for the modifier methods, of course. And as a plus, they do offer some sliding capabilities in terms of the window we see into that continuous sequence by modifying the prefix or the suffix of this range. Helpful in string processing, I would say. So it's a lightweight string-like view into an array of characters. It can be constructed from a null-terminated string, more on that later, or from a pointer to a character string and a length. And it is intended to play well with string literals and in context per context. Its design goal is to avoid unnecessary copies of standard strings. And it was designed to interoperate well with standard string. We'll see some of the conversion operators involved and some of the conversion constructors related to this. But although it's a very neat and apparently simple helper, it does come with some usage complexity, as we'll see. It's very helpful in many situations, and it's very tempting to use it, but it does come with some gotchas. But first of all, why are we trying to avoid temporary strings? Well, they're not exactly small. They hold at least 3 pointers. They can cause memory allocations. Small string optimization mitigates some of these issues. And we do have to copy data around. And implementations using something like copy on write for some custom string types avoid this issue. But if we're talking about interacting with standard strings, that's off the table. And string view does not manage its storage. As opposed to the standard string, the lifetime management of a string view is the responsibility of the caller, of the user. So it's basically just a handle type. So when would we use a string view instead of a standard string? Do we just replace all our usages of standard string? Of course not. Can we safely use it everywhere when we have to interact with some platform-specific string and use string view as a common denominator because of its conversions? Well, let's see. First of all, let's examine some of its constructors. The usual suspects, like default constructor, copy constructor, and we have a constructor that constructs from a sequence of characters and a count, and one that assumes a null-terminated string, keyword being assumes. What can you tell me about the one I'm pointing at there? It's useful. It happens a lot when you don't even know it, but it does come with a cost. So assuming a null-terminated string, first of all, it really has to be null-terminated, and you do have to count the number of characters in there until you reach the null termination. So it does come with a performance penalty in situations where you really know the length. Go. I wouldn't do that. Yeah, you can. You can, as opposed to standard string. You may pass. Yeah, I think it's OK. So this is the costly constructor. And why I'm pointing this out? Because frequently, I've seen situations where people actually unwillingly or without their knowledge actually fall back on that constructor when it's not necessary. So they're needlessly calculating the string length. We're not talking about very long strings here, but it's a cost you don't want to pay for. And it may happen at compile time or not, depending if it's a string literal or if you're in a const expert context. So let's see on the other side for standard string, because standard string was revised to be able to play nice with string view. And standard string gained a conversion operator to string view. And it basically constructs it as string data and string size. And it returns a string view of that type. So if we were to sum up all the conversions that can happen back and forth, a standard string is constructible from an array of characters. A string view is constructible from an array of characters. Standard string automatically converts to a string view via a conversion operator, like we saw. And you can construct a standard string from a string view via an explicit constructor. OK. Manageable. Sounds OK. Let's think about storing string views. Short storing being don't. But let's see some compelling examples. We're talking about storing string views in your classes or in containers in general. Let's see. We have a vector of string views, elements, and a save function that takes a string by const reference. Let's say we have this utility method. We already have it in our code base, and we decide to change the storage and store them as just views into some external strings. Because we say we don't need to copy those strings, right? We're just processing them. Automatic conversion, no compiler warning. And we basically end up potentially hanging on to dangling references, because those strings can be deallocated. We don't have any control. We don't have any knowledge of their lifetime. And you can easily hang out to dangling string references in your vector without even knowing it, because you have a disconnect in ownership responsibility there. Another simple example, the other way around now. Let's think. We have a map with string keys, standard string, not string views, and we think, OK, let's use it as an argument. Let's change the signature of our getFrequency for keywords method from taking a constant string ref to a string view. And we return the frequency of a given keyword. This doesn't compile. There is no conversion to standard string. Everyone OK with this? So if we're trying to use the map at method, because the key is a standard string, we cannot actually do this. Intuitively, you would think it would work, but it doesn't. OK, let's explore this a bit further. What if you're using a transparent comparator, like standardless here? Let's implement a getFrequency for keyword another way, by using this transparent comparator. Again, we're taking a string view as a parameter, and we're storing standard strings in our map. All right. Well, batteries included. A string view does come in the box with operator less. So you can actually use a transparent operator to implement something like that. So this is a workable solution. for our example of keyword frequencies. So string view does come with a collection of utilities, like all sorts of combinations of operators, like less than, equal, and so on. So I generally tend to use high warning levels and treat all warnings as errors. And I generally am very comfortable on relying on my compiler to help me and point out mistakes or potentially dangerous situations that I might use. Well, not so well. Sometimes our compilers fail us. Let's see a simple example. We have a sync. We usually call this idiom async. We have a parameter for a constructor, and we store it directly into our member. Pretty standard stuff. If this was a sync that took a standard string by reference, this is almost idiomatic code. If you're not comfortable with the std move, you can even ignore that part and just assume we're copying it. But let's analyze the situation when we try to replace the string reference in the constructor with a string view, like we have here. Should this work? Does this compile? Well, yes, it does. Is this safe? What do you think? Is this safe? OK. Why does this compile? That would be the question. Well, we have an, yeah, I heard something in the audience. We do have an explicit constructor for standard string that says something like this. I can construct a standard string from any type that is convertible to a string view. And I can initialize my standard string with it. And conceptually, it converts that t argument into a string view as if we would assign and initialize it. And then initializes the current string with string view data and size and optional allocator. So this explicit constructor is only defined for t's that are actually convertible to string views, so not any type. But the advice here would be, although this works, don't try to do this. And the idea is avoid at all possible times to actually store something that came through a string view. Why is that? Because you might have a longer chain of actually passing this handle. And you have no certainty in actually knowing if that handle you have and you received as a string view for the sync argument here, you have no way of knowing the source of that string. Is the string that the string view points to still around or isn't? So storing here the handle inside that string view in our standard string it's actually potentially dangerous. So the advice would be, if you know that you ultimately are going to end up with a standard string in a chain of passing around the buffer to some string-like data, avoid at all costs mixing them up, passing from a string to a string view to a string, and if you ultimately end up storing a string because you need to actually have a copy of that string, avoid passing through multiple combinations of string views. So never mix them up into a a call chain like this.
Just to make sure I
Yeah.
understand. The constructor you showed that doesn't make a copy, it stores the pointer to the
Yeah, it
buffer.
moves it, yeah. I can show it again. Question? No. I saw another hand go up? No, sorry. So this actually burned many people. Actually mixing function calls like this. Some function calls, imagine you have a call stack, and some functions on that call stack have a const string ref, and some of them have string views, and you end up storing somewhere a view into a buffer as a standard string. This actually came up for many people, not just for me. OK, so my compiler failed me this time. Basically, it let me do unsafe things. What else is new? Maybe static analysis tools will help me with some checks regarding this. Who here has used ClankTidy in any context before? OK, cool. This is a great opportunity to plug my open source project here. So if you're a Visual Studio developer and you have LLVM Clank tool envy, and you want to bring all that goodness into your Visual Studio IDE, you can use this free Visual Studio extension. It's an open source project that a few buddies of mine and I started. And you can definitely try it out. So let's see. ClankTidy comes with lots of checks in the box. Some of them with auto fixes, very good stuff. Checks for readability, for unsafe practices, for gotchas, all kinds, modernization passes, all kinds of goodies. And the first thing I would do, I would go there and try to see, are there any string-related checks that I can use? There are plenty, very good stuff, string-related checks. But if you scan that list, nothing related to string view. Pretty sad. Oh, wait. You have to look a little bit closer. There's a tidy check called bug-prone dangling handle. Sounds very menacing, but it is. So it turns out this actual ClankTidy check is actually very specific to string view. Theoretically, it's configurable to use other types of dangling handles like string view, these no-knowing resources. But its main scenario in usage is string view. And it does catch some of the obvious situations, but not all. So I highly recommend that at least you do this pass in trying this ClankTidy check on your pattern. So it's basic detecting dangling references as handles to string views. Dangling references can be a result of constructing handles from temporary values where temporary is destroyed soon after a handle is created. Keyword here being soon. This is where the tool gets lost and it's no longer able to help you if there's a too longer disconnect chain between the actual ownership or the allocation of the string and the dangling point. So if the usage is pretty well localized, the tool will help you. And this is the URL for documentation for later reference. Let's see some string literal context. We do have predefined liters. Like I said, string view does come with goodies in the package. And it does have a string literal suffix, SV, that you can use for compile time strings. What would you say the length of S1 would be here? So what would this print? 3? And S2? OK. Well, it wouldn't be a C++ presentation at least not a serious one without some gold bolting. So let's see if we're right. This is pretty messy. Nothing we can read out here, but let's try some optimization. Oh, look at that. So we do have the result here in the EAX register, the result of the size, because it is a compile time string. And let's see how it works out for S2. Okay, Bjorn was right. Okay. Let's see. Let's get back to it. So, surprisingly or unsurprisingly for some of you, actually sticking null terminators within string literals might be surprising. What if I want a null terminated string from a string view? Well, this actually circulated a lot with some of my friends on Twitter, and some of them proposed various solutions to actually extracting a C-like string from a string view, like a null terminated thingy. And one possible solution would be this. Would you like to see something like this in your code? Do you think you deserve something like this if you try it? I don't know. I wouldn't know what to say about this. I would be reluctant to use it. So I was determined that I wanted some string view in my life, and I still thought that string view would solve many of our problems in interoperating within various types of APIs within our source code. And then I went to this talk at CPPCon last year. And Nico did a very nice presentation, and I put the URL there to, if you haven't seen it, I highly recommend that you do. But it scared the hell out of me, and had things in it like string view is a nightmare. I'm literally quoting. String view is worse than a string reference. String view is semantically a string reference, but conceptually a value type. Well, kind of true. That was basically me during the presentation. And the compelling example that he gave, so this is Nico's example, is a function template that presumably doubles a string. And we do have the string view plus operator here. And we have a string view, long string view there. And we say auto r equals double of string view. And we try to print the result. And we have a runtime error. Does anybody see the problem here? There is a problem. Why do we have a runtime error here? Well, sorry?
Because the return type is also
yeah. So it's all about that T return type of the double function. So that's the problem with that function. It returns a T, and T for us is a string view. And we're masking this option, this problem, because we're using auto R, like good people, you know the pattern, always use auto. So we're being good citizens and using auto and masking this problem. So Nico actually says that almost always auto pattern is broken with string view. And this is a very toy-like example that it's broken. Imagine what it could happen with much more complicated stuff. So the lesson here would be, don't assign something that came from string views in auto. Well, That's kind of disappointing. I actually took this screenshot while I was there, because I was obsessed in digesting these issues and investigate them on my own. And he says basically what I did. And a solution here would be to use, surprisingly, auto as return type of the double function here. And because we're using auto as the return type of the double function, what changed for us? Can somebody tell me what changed? We're still using auto R when we're assigning, and now R is a standard string, so we're fine. All the clues are on the slides. No, I don't have any more reveal animations. So everything is on the slide. What changed? We just said auto double T when we defined the double template function. What changed?
We're not constructing a temporary string.
Yeah, because the plus operator is actually defined to return a standard string. That was the case before as well. I didn't change that. You see? Operator plus returned a standard string before this. So I didn't change a thing there. All I changed, rather Nico did, was the return type of the double function. So now the function template properly uses the return type, the exact return type of the plus operator there. It's no longer using T that is deduced by the argument, which is a string view. Fairly simple mechanical stuff, not at all obvious. So that always bugs me. When the explanation is not complicated, but I missed it when I first saw it. So apparently very simple stuff for any seasoned C++ developer, but you can easily miss out on these things. Small stuff that bites you. So we're good now. Several people noticed problems like this. Very smart people are trying to solve them. A few of the issues are fixable, let's say. There is a paper in flight, proposal P0936. Very smart people are on top of it. Nico is one of them, along with Richard. And hopefully, I highly recommend that you give it a read. If I piqued your interest regarding string view, it's a very short paper, has 5 or 6 pages. So it's definitely something that you can browse through very quickly. Has a very nice rationale and explanations, a few interesting examples, and what they're trying to fix. So it's not going to be perfect, not even if this paper goes through. It's nothing certain at this point. It's something considered for C++ 20, but I highly encourage you to read it. It's not at all very difficult or very technical. So a few months passed after I saw Nico's talk, and then I attended Meeting C++, and I saw another great talk by Mark Mutz. He works with one of the main contributors on Qt, or Qt. And the title, when I saw the title in the program, I said to myself, I had to be there. So string views everywhere. So this is an opposing view to Nico's more cynical and depressing talk. This actually was a more enthusiastic talk and embracing string views with all its words. And it does have quite a few references to QString view, which is the equivalent of string view for QString in Qt library. But everything that Mark explained in this talk definitely applies to standard string view. So there's nothing specific to Qt there. And even the examples in the talk are string view based. So I highly recommend that you watch this talk. It clearly defines his views on safe guidelines and safe places to use it, like some of the situations where you can take it safely as function parameters by value. And after I saw that talk, I was a happy camper. I said, I gained confidence I can do this. And I started with more enthusiasm, so to speak, and a little bit more courage to look around and read some more material on this on the web and see what others are saying about it and playing with it myself in some examples. And there are others to help. There are some very good resources, some good blog posts about this. I did a little, built a little collection for you guys if you want to read up on it. There's Jonathan Mueller's blog, a very good technical blog to follow in general for C++. And it does have 2 entries for string views. String view accepting temporaries, good idea or horrible pitfall. He later relaxed his views on that. And a more general article regarding guidelines for R-value references in APIs. This is clearly applying to string views as well when we're talking about return types or parameters for our APIs that we're building. So definitely a great resource to read through. I don't have the time in this talk format to go into the details that he explains there, but I highly encourage you to read through. Another interesting article that is not focused strictly on string view, but it talks in general about strings competing constructors and various similar issues that come with standard string. I don't exactly know how to pronounce his name, so I won't even try. I won't even try, so, but definitely read through his blog. He usually writes very good stuff. And my favorite article on string view is Arthur O'Dwyer's. And he also runs a very tight C++ blog. Good stuff regularly comes there. And he says string view is a borrow type. What the hell does that mean? String view succeeds admirably in the goal of drop-in replacement for const string ref in parameters. Well, yeah, that was what it was designed for. The problem is that there are 2 kinds of types, of object types. We have object types and value types. Object types are what other languages call reference types, even C++ terminology. So we do have reference types and value types. And string view likes to pretend it's a value type, but it's not. It gives you the impression that it's a regular type and plays nice with the type system. It gives you the impression that it's a value type, but it's actually a borrow type. What is a borrow type? A borrow type is a handle. We've seen this before in C++. It's not exactly new stuff. So string view, because it lacks ownership, it actually holds a reference to another object without holding the ownership to it. And is meant to be used with buffers that are short-lived, usually on the stack in that frame. Not something that is way down the call chain. And you can usually do without an assignment operator, although for string view it's not the case. And it can generally appear just in function parameter lists. And it's not meant to be stored in data structures or returned, for that matter, from functions. So perhaps string view is the first mainstream borrow type. I said that this is not the first. We've encountered this before in C++. But this type, string view, is the first C++ type that has the potential to be a very dangerous tool, because as opposed to other types that have similar behavior or similar handle semantics, this one has the potential to be dangerous because it's very attractive. It's something that sounds very mainstream, something that sounds very appealing to everybody using C++. It's not some esoteric library type like, I don't know, reference wrapper or tuple or whatever. this one sounds very mainstream. Sounds like something I would want to use immediately as I learn C++. So that's why I insisted it's dangerous. It's not something that's brand new in C++. The concept of a handle type has been in C++ for years. But this one has the potential to hurt us because it's something that's very, very deceivably simple and attractive to use. Hey, it deals with strings. What could go wrong there? And it is assignable. Another questionable decision that was made about this type. And the problem is that the assignment has shallow semantics because the views are to constant string sequences. And the comparison function has deep semantics. If you compare two string views for equality, it actually checks the corresponding buffers to see if they're semantically equal. But the assignment is shallow. It's just assigning pointers into some other location because it's a handle type. So it's, again, not exactly a regular type there. And problems like this will continue to come in C++. C standard span is on the horizon for C++ 20. Maybe it will happen. My personal opinion, standard span will bring even more pain than string view because standard span comes with all the problems of string view, plus the fact that it's a view into a non-continuous, non-constant sequence of whatever. And we'll have to deal with that when it comes to be a part of the standard. So a solution would be to be very careful about the places where we actually use string views. I still think that string view is something that we do need, and it tries to solve a real problem. And we can safely use it as long as we constrain ourselves to using it for function parameters. And we pass it by value because it's basically a structure with integers inside. And try to avoid mixing a call chain where we have functions with string views as arguments and functions that pass a regular standard string, and avoid that mixing of string and string views, like I said earlier. So as long as we're civilized in using it, as long as we properly adnotate the places where it could be potentially dangerous. For example, it is OK to return a string view. For example, you return a narrow view into some larger buffer. It is OK. It is justified. It is helpful in these situations. But you have to be very explicit about it in terms of properly documenting that behavior and warning the caller that they better know what they're doing in terms of that string view is into a buffer that resides elsewhere, and you have to be sure by construction that it's still there while you use it, and you don't hang on to some dangling reference later on. So my take on it at the current time is that I still want to use it. I still find it very, very useful. I still find it very efficient for glue code and in general for avoiding temporaries when dealing with strings. But I urge you to be very careful when defining APIs with string views and document properly the usage. That's about all you can do. You cannot enforce the usage of those APIs. But as long as you properly document, that's a precondition for usage. And if the callers don't agree on that, then it's their fault. As a conclusion, I would say Marco Arena has a blog post about string views as well, an older one, but still very, very good. And I agree with him that string view odi et amo. I hate you and I need you, so to speak. And it does solve a real problem, but it does come with gotchas, and part of what I'm trying to do is try to spread some of the issues and the pitfalls and make people aware of the responsibility that comes with such a useful and dangerous tool, because it's deceivingly simple. Like I do with all my talks, I try to pitch the social communication channels and news about C++. If you're not on the C++ Slack, do get on there. Very good discussions and dedicated channels for various conferences and various topics, even standardization and papers in discussion. Do follow the C++ podcasts, CPP Cast by Rob and Jason. Weekly stuff, very good stuff, excellent guests, news, and discussions about articles. And a reboot of an older show like CPP Chat by John Kalb and Phil Nash. It comes in podcast and video form. You can get involved. You can even type in your questions live and get in the conversation. And they usually have very, very good people invited, and discussions are excellent there. It never disappoints. That's about it on string views. If you have any questions, feel free to ask now or later. You can find me. Any questions? Sure, yeah.
I wonder what your opinion is in the case of functions that return string views, which are obviously problematic in the normal case. But if I have functions that can return compile time known strings only, what is your view on that?
So the question was, I mentioned earlier, functions that return string views and potential danger situations there. What's my take on functions where the string views are into strings that are compile time strings? So if you were to be in a const per context and you know for a fact that you're dealing with string literals or compile time strings like that, I would say there's no problem there. And I find it very useful in actual processing. For example, if you're trying to match some kind of a pattern or strip some kind of parts of a buffer or have a sliding window into some kind of input buffer, as long as that string is something that's compile time, I don't think you can be beaten by problems like this.
I wasn't wondering if it was safe or unsafe. I was wondering about the idea as a convention, because it should, I think, surprise most readers of the code. So
You mean if
you see a warning sign that, wait, this is a function that returns string view. This is phishing.
Yeah, you mean if it has the potential of being idiomatic in usage in context of compile time strings, or might it surprise readers of the code if they see string view as a return type? It might, because although you might be thinking of that API as intended to be used in a string literal context or in a compile time context, they might not be aware of that. So it might surprise them, or it might make them avoid using that API. It might, especially if they see this talk. So it's a double-edged sword there. People would, if they don't know the API very well, might avoid it. I'll give you that. Yeah, Adi?
I find something else bothersome. You know, when you're using a standard vector, they always tell you that you have to beware that if iterators might be invalidated through inserts and inserts. So
Yeah.
there is a warning that comes with using iterators in such a data set. Now let's say I'm writing a library that parses command line arguments. So they're not string literals, but they're basically guaranteed to always be present Or another example, somebody wrote a library to parse JSON, a very, very large chunk of data. And I see no reason not to hold these values. I mean, I find it difficult not to hold these very light values inside some kind of data structure and say no, because this might go out of scope at one point in time. I'm going to bear the cost of all these copies of stuff.
Yeah.
I think the guideline that says not to put string view inside containers, for example, is very difficult for me to digest when I'm talking about if the cost is responsibility, like I had to do with regular iterators, versus all the copies I have to make.
I'll try to very succinctly summarize what you just said, just for the audience. So Adi said that, for example, in a scenario like where we would process some command line input string, you wouldn't want to pay the cost of storing all those sequences into, for example, a vector of standard string, and he would find it very appealing to just use a vector of string views there, because he knows the input is still around while he's processing that command line. Did I summarize it right? Okay, I totally agree. What I am mostly scared of is when we're defining libraries and APIs for the others to use. So if you have some business logic code, for example, you have a method that processing that command line, like you said, and you know that by construction, that buffer is still on the stack while you're processing it, it's totally OK. But I'm more afraid that people would start to sprinkle string views within the APIs of their classes and libraries. So that's where I see the danger. When you're trying to write reusable general purpose code and you're designing APIs that are potentially unsafe. And you're right that you alluded earlier to iterator invalidation in terms of STL containers, and that people are aware of these issues, and that it's something that it's well known by C++ developers. There are operations that you perform on your STL containers that invalidate your iterators, and these tools come with knowledge that you need to have before you use them. I totally agree with that. But string view is not yet at the popularity level that gotchas are well known, like iterator invalidation, and it's not. We don't have yet an idiomatic usage for them. People don't exactly agree on what's good and what's not. And maybe in a few years, the situation will be more relaxed. People will be well educated. That's what I'm trying to do, in terms of be aware of this and that, and then you can say, okay, I know what I'm getting myself into. I'm going to use this, but I know what I'm doing. This is the C++ way. I'm using this. It's a powerful tool, but I know what I'm doing. I know this string is alive. I know I'm processing it. It's still on the stack while I call this function. I'm all right with it. Yeah, and the problem is that many places in the standard library and in the C++ language in general, there are many unsafe corners, and people have been hurt. But this is still new. This is still a corner of C++ that needs more popularizing. If you search the web for string views, you will find very few articles. I basically listed almost all the articles related to this. So it's still a brand new resource. People are still not comfortable and knowledgeable and don't have real-world experience in using it. And that's why I see the danger, because it's something very simple, deals with strings, and very dangerous if you're not using it right. So I totally agree with you. I would do what you said, but I wouldn't design it in a general purpose reusable piece of code like a library or something like that. All right, I think we ran out of time. If you do have more questions, catch me. I'm still around here. Thank you very much.